Dear participants, just will wait for 2 minutes. Already the speakers are joining. Just now I called them, so they will join within 2 minutes.
Srilata madam, am I audible, ma'am?
Yes, ma'am.
Okay. Ma'am, shall we wait for 2 more minutes, ma'am?
Yes, sir. Let them. Yes, ma'am. Let them join.
Okay.
Already they are trying to join.
Okay. Shall we start the session, ma'am?
Yeah. Pratik sir, are you there?
Yes, ma'am, I'm here.
Yeah. Amir sir?
Yes, ma'am. Hi, I'm here.
Yeah. Okay, sir.
Good morning to
Let
each
me
one
share
of
the
you.
screen.
Yes.
Let me share the screen.
Yeah, ma'am.
Go on, ma'am.
Okay. Good morning to each one of you present today. I welcome you all to the day 3 session of 1 week online FDP on Digital Transformation in IIoT Industry 5.0, organizing by Department of ECE, Vardhaman College of Engineering. Today, the schedule of FTP will focus on the topic of AI convergence and Industry 4.0. It's a moment of extreme pleasure to introduce today's speakers, Pratik Vasista sir, subject expert, Intel FICE, Bangalore, India, and sir, subject expert, Intel FICE, Bangalore, India. So, developing applications in areas of artificial intelligence, machine learning, AWS, IBM Cloud. Pratik holds rich experience in building and managing projects from MNCs and government organizations. He has worked with people from different countries, regions in India, and with diverse backgrounds. He is an active member of open source community developers and enjoys writing technical blog spots. Pratik is passionate about sports and travel and loves to interact with people. He resides in Delhi. So I would like to introduce one more speaker, Mohammad Amitzar. He is a highly skilled, experienced technical professional in the field of Internet of Things and artificial intelligence. Amir is an innovative professional with years of experience in technical solution development, content curation, and content delivery around IoT and artificial intelligence. He has delivered a numerous number of technical sessions, webinars, and workshops to varied set of audience around IoT, computer vision, automation, and AI. He is also certified in RPA with UiPath Associate Level certification. His key technical skills are technology, artificial intelligence, machine learning, data science, IoT, RPA, and programming Python, embedded C, and cloud IBM, AWS, and frameworks TensorFlow, SCI Kit Learn, Flask, Streamlit, and UiPath. He undertaken projects like real-time face mask detector using TensorFlow and OpenCV, and number plate recognition using ELO, and weather station sensing and forecasting using time series, and tongue-controlled wheelchair using Arduino Bluetooth. And he conducted more than 200 workshops covering pan-India, catered to more than 8,000 participants on various technologies. He is also a member in Times of India NIE 2020. His area of interest are machine vision, data analytics, artificial intelligence, and Internet of Things. So once again, I welcome you, both of you, sir. Please take over the session.
Thank you so much, ma'am, for a very nice introduction given to us, and a very warm welcome to all the participants in this session. Just allow me a few seconds to share my screen. I hope my screen is now visible to all.
Yes, sir.
And I hope I'm clearly audible as well.
Yes, sir.
Thank you, ma'am. So once again, a very warm welcome to all the participants here. And this session, we will be talking about the latest technologies. We'll talk about the convergence of artificial intelligence with other latest technologies, and that has bring up the fourth industrial revolution. We'll also talk about fifth industrial revolution. That's about the human-machine interaction. Moreover, we'll also, in this session, we'll discuss what are the challenges that we face in terms of implementation of such technological solutions, and how these challenges can be met using Intel technologies. Finally, we'll also have some hands-on activities as well in this session, and we'll make sure that majority of the portion will do the hands-on activities, where we'll give you a walkthrough about the actual implementation of AI, IoT, and the combination of technologies like cloud computing as well, and how these technologies in collaboration can build up solutions which could be at the very elementary level, and which could be also at the very high level sophisticated solutions as well. So to begin with, we first need to understand what artificial intelligence. I am sure most of you already know that. So as we say, by definition, that artificial intelligence is a science where we try to build, or we focus to build machines which bears an intelligence similar to human beings. That means a machine should be able to act like human beings, should be able to behave like human beings. And when we say act and behave like human beings, that means the basic human activities. That means a human being can walk around in space. And when we walk around, we don't collide with the objects around us. That means we are able to find the best path to move around. We're able to see the objects around us. We can perceive our environment through vision. We can understand languages. The natural language understanding is something very common, very simple task for human beings. So all these tasks, we want machine also to simulate the similar activities, similar behaviors, should have these capabilities. And that is where we say we are bringing in the artificial intelligence into a machine. That means we want machines to be able to move around, to be able to identify the objects, also differentiate between different objects. Also, the machine should be able to, for example, should be able to differentiate between colors, between shapes and size, should be able to identify the motion, and should be able to differentiate or identify the relative motion as well. Should be able to understand the natural language. That means a machine should be able to understand the human language, understand the meanings, syntax and semantics of the language, and using that should be able to generate the text or maybe the audio signal in the in one of the human languages. So that is where we say we are bringing in artificial intelligence to a machine, and to do that we use various other techniques. So one of the common technology that we commonly hear about is machine learning. Machine learning is that science, or I would say a practice that gives the capability to a machine to have a learning capability. That means a machine would be able to learn through the experiences. Or in other words, I can say a machine should be able to learn through examples. That means if I provide certain examples to a machine, it should be able to find out the patterns out of the examples. Process should be able to support us to build more efficient and productivity, bringing more efficiency and productivity in any of the tasks that can be done by human beings, and also in modern times can also be done by machine along with human beings. So that is where comes in the machine learning part of it, and that's what helps us in the implementation of artificial intelligence. Now, when we say implementation of artificial intelligence, it's not only the simple machine learning methods. There are deep learning methods as well. So deep learning is a subset of machine learning that utilizes artificial neural network concept, which allows an automated feature extraction, feature identification, and selection of the features, and then perform the certain kind of inference rules, inference generations, finding the patterns from the data, and then deriving the conclusions out of it. Or in simple terms, I would say, or in direct terms, I would say, then finding the proper classification of data into one of the categories. So there are simple machine learning algorithms, primitive algorithms, and there are deep neural network, or I would say deep learning algorithms, which are there. Now, when I said that we need to supply some experience or examples to the machine to learn through it, to develop the learning capability, we need number of examples for a machine. That's what happens with human beings as well. Until unless we experience number of different I would say the variations, we won't be able to learn about different possibilities in future. Similarly, a machine needs to explore the various possibilities to come out with a proper conclusion. In future, if it encounters something similar, it should be able to identify that, okay, something has already been encountered in the previous examples, and the probable decision making or probable output or probable action that can be taken could be something which is already known through the experiences. So for that, I need to provide n number of examples, and these examples for a machine are in terms of data. And when we talk about data, data is generated with a huge quantity and huge velocity as well through various sources in the modern times. Whether it's social media, which is generating a huge amount of data with high velocity every second or every instance of time, whether it is any machinery, which is also connected through some sensor based systems, and it is continuously generating the data regarding the operational activities of a machine, maybe a temperature, maybe the rounds per minute, that is the rpm of a moving part. Fine. So these are the some can be given as an input to a machine to find out the patterns, generate the learning capability, and then take the intelligent decisions in future or intelligent actions in future. And we also want these actions to be correct always. We don't want to have errors. So we are looking to have a most optimized form of actions or decisions taken by a machine. So this data is very easily available nowadays because over social media, or whether there is a factory where machines are working, we do have sensor based systems. We do have mechanisms to capture the data. We also do have mechanisms to store the data efficiently. And the only thing which is required for implementation is the optimized mechanism to utilize that data for machine learning capabilities, for artificial intelligence implementations. That is where artificial intelligence comes together with IoT. IoT is Internet of Things. And this is where we work with machines that contains the sensors. Sensor-based systems are available, and these input sensors provides an input data to an AI-based algorithm, and these algorithms then in real time can process that data and bring about the inference or outputs or actions which is intended for the particular solution. Some examples, if I talk about, whereas we have a combination of AI and IoT, one of them very common example is the virtual assistants. It is very common that we are using Amazon Alexa or Google Nest or even the Android assistants, Google assistants. In our Windows-based systems, we are using Cortana. So all these are the virtual assistants. Some of them are the text-based, and mostly nowadays we have the voice-based virtual assistants available, which captures your voice signal, tries to understand the natural language. Again, the AI-based algorithms are used, and using the understanding from the natural language, it is then able to decide upon the best action or response, and that response is given back to the human being. Now, these are very extensively being applications with your desktop applications as well. These are being used in the customer sites, in e-commerce websites. This is being used in the kiosk, in the markets, in the supermarkets as well, so that it gives a customer a greater experience, a convenient experience to bring out the solution what a person is actually looking for. Agriculture is another field which is very extensively now people have started using AI and IoT based systems. This is where in the agriculture fields we can have sensors installed, an array of sensor actually installed, which will in real time keep sending the data to a base system or a base location, which can store the data in the cloud. And from the cloud, the AI algorithms using the cloud-based servers itself, which are very high in configuration and sophisticated systems, can quickly generate in real time some inferences. It can detect whether the supply of water to the agriculture field is appropriate or not, whether it is more than required or it is less than the required for a specific type of soil or a crop. It can identify the temperature, atmospheric temperature and precipitations. It can also detect through some camera sensors, it can find out whether there is an attack of any pest, or there is some damage to the crop is being done, or maybe the field or the crop is suffering with some kind of disease. So this is where agriculture is also using IoT and AI based systems. In the modern times, the best example we have for these kind of collaborative technology is autonomous vehicles, which uses a very sophisticated IoT sensor systems, artificial intelligence backed by deep neural network algorithms, cloud-based systems to hold the huge amount of data in real time. And there is petabyte of data which is generated. The security of person traveling in this vehicle and security of people on road, security of people in other vehicles is the prime concern while taking any of the decisions. Apart from this, we also have retail shopping area. This is very common in India, but in foreign countries, in US, when you go out, you'll find there are shopping malls, shopping areas where the sensor-based systems are installed, which will allow you to find out the best product, to also find out which you can compare the products and you can find out which product offers you the best discount and deals. Then accordingly, it will keep the packed items from one rack to another, from one location to another, and there is no human intervention required. So these have the sensor-based systems which can identify objects around them, which can identify the obstacles as well, can move around, finding the best path and shortest path to move from one rack to another or from one location to another, and then can also carry the packets with them, carry some kind of a workload, and this payload can be delivered from end to end without human intervention. This reduces the requirement of human beings walking very frequently from one place to another in the warehouse, and also reduces the cost of maintaining the warehouses as well. In sports area as well, we are extensively using AI and IoT solutions where players are wearing the wearable devices, and every moment they perform is being recorded in terms of a player on a specific day, and based on the data analytics solutions as well, it is combined together, and these data analytics will tell you what has been the performance of a player or a team in the past and how it is projected that their performance would be in the current match that is going on or in the current play, and also detecting the real-time situations, real-time body sensors are there, wearable sensors, device sensors are there. So in real time it can capture all those parameters, and then can find out what would be the performance on a specific day, and based on that some decisions can be taken. Security systems, whether it is data security or physical access using biometrics, can also be backed by AI and IoT systems. It is very common nowadays. You'll find in market there are padlocks even available, which are biometric padlocks. It runs through your fingerprints and fingerprint recognition, and you just have to register your fingerprint, and then it will open only once you provide the correct fingerprint to the sensor. And this has become very common and very cost effective nowadays. Even in the online storage of your data traveling through network and data at rest is provided with a high level of security backed by AI systems. The firewalls and IDS systems are also backed by AI algorithms, which can detect the pattern of attack. It can also able to find out the distributed denial of service attack, and can stop and mitigate the risk of those attacks. Field of education, there has been number of applications being built. In market, there are applications available which will automatically mark the attendance of students who are sitting in the class, who are available, who are present in the class. How it does that? It just captures an image through an high resolution camera, performs the face identification and face recognition activity phase wise, and then it will after identifying the individual in the class, it will mark the attendance in the database automatically, and that can further be verified by the faculty or the teacher who is available in the class. That's what is saving a lot of time. You can save an extra 5 minutes in your classroom, and then you can cover up few more concepts and examples with your students. You'll not bother about maintaining the registers physically, and this attendance system is very accurate in identifying the student through their face recognition. The healthcare industry, the devices which are being used to monitor the health conditions, whether it's an X-ray or CT scans or MRIs, these are also now backed by AI and IoT systems, which uses image processing to find out the very minor details in these scans, which is not possible through a naked eye, even by an expert, to detect the anomalies, the abnormalities in the scan, or the minor details which in future might lead to a serious medical condition of a patient. And that is being detected by AI systems in modern times. And there are labs being set up, there are instruments which are backed by these technologies, and which is where the number of patients, they got their diseases diagnosed at a very early stage, and they got the proper treatment, because of which they were able to save themselves from the disease in future. Home automation, although not very common, but in future we focus on having an home automation systems available in next 2-3 years. it is projection. These will all be connected through a Wi-Fi network in home, and all this not only connected to a Wi-Fi network, we should be able to control them, switch on, switch off them, perform any activities with these devices, switch on the lights, switch on the fans, and switch off whenever it is required, just through a mobile application. And that too is done using the technologies like IoT, technologies like wireless networks, mobile applications, Android applications, and there would be an AI application which would also allow the automatic switch on and switch off of lights, fans, and AC systems whenever any person enters a room, and it will automatically switch off when person or all the people from the room will leave the space, and there would not be any human being available. So that is how the smart home systems would be in future. It's the very hot topic nowadays. We talk about Industry 4.0, and this is where the production units in the industry, they are extensively using technologies backed by deep neural networks. We have computer vision and Openvino technologies, which is helping to identify and maintain that it is able to. Is there any problem with the production line? If there is any problem, if there is any anomalies which are detected, these are detected by image processing. Quality in the assembly line, and this quality maintain a very high quality in their production line. Another technology that comes with AI and IoT is that edge computing. So edge computing is where we are delivering these services at the edge location. And to deliver at the edge location, we definitely need the combination of hardware and software technology that would be able to perform the computations on with a very high optimized programming solutions. And that is where not only AI and IoT, the cloud computing technology has proved to be very useful, which has allowed us to deliver I would say, deliver the solution at the edge location with a very low latency and high capacity of processing as well. Hybrid workforce is something what we aim to have in future, and that's what we call as Industry 5.0, where human and machines will come together and build the solutions all together at one place. Now, moving on, not only AI and IoT, we also have cloud computing, which is helping us out. And in combination of AI, IoT, and cloud computing, we are able to effectively develop the machine learning models, deep neural network models, and these are being hosted in the cloud environment, which allows us to process the huge amount of data in real time, store unlimited amount of data, and also perform the very high performance computing in the cloud environment using the cloud servers running in cloud data centers. Why this has been very useful for us? Because the high storage requirements, the requirement for a very high computation power, the requirement for continuous availability of service and high availability of service, where n number of people or entities are trying to access the service, can be achieved through cloud computing. There is an easy scalability in cloud. So cloud also provides us with, we can scale up and scale down, and we can even scale out to multiple copies or replicas of the instances, or I would say the high capacity servers and storage can be scaled up easily. And when it is not required, when the high capacity is not required, it can to read on-premises infrastructure. If we use cloud, it would be more reliable because it is being maintained properly with a team of experts, and there are a number of data centers geographically distributed to different continents, different regions. Data center is not working, the load is. I'd like to show you a small demonstration to just give you an idea what kind of applications we can develop and how easy now it is to develop application learning, and can then help finding out the most. I have some example data which I have provided to my machine. And I have asked this machine to learn through these images, and these images are of different sizes, different types, or belongs to different patient as well. And there are some labels attached with these images. If you can see, it's an COVID patient chest X. Here we are looking to find out whether a patient has a certain amount of pneumonia condition or chest congestion related to pneumonia or not. So there are COVID patients whose chest X-ray images are being supplied to a machine, and this is over 100 images we have supplied. And there is another set of images labeled as normal as well. So there are images which are termed as normal. If through a naked eye, if I look through these above and below images, person with COVID and without COVID, uh, to a I would say non-medical person, it would be very difficult to find out which one is belonging to COVID patient, which one is the normal patient. Even for most of the medical technicians, it is not easy to find out whether a person is suffering with a COVID-induced pneumonia or not. But for a machine, it is easy to identify because a machine can process these images pixel by pixel very deeply, a deep analysis images, and it would be able to identify the correct labeling. So if I have to use this model, what simply I need to do is I can just simply uh, import some image. So for example, I'll just move to, just give me a second. I'll move to a directory where, fine. So I have, where I have these some sample images which I can use for testing this model. So I have already trained this model and I'm using the validation images. So if I selected the normal one, so in any case, even machine could not be 100% accurate always. So it might not have generated the correct predictions in this case. So what I can do, I can just simply say the no, that it does not belong to the COVID patient. And now it will again get trained on the data which is supplied to it. So along with the examples already existing with this machine, on the left hand side, you can see training process is going on. And when this training process is going on, it is trying to again generate new conclusions out of the input images which were already provided and a new input image that has been provided just now, and which is where machine was not able to detect this correctly. So this is where machine is again retraining itself and trying to generate new conclusions, find out new patterns. Okay, so for normal patients, a similar kind of image can be provided in future. If I again go back and supply some other image, which is a COVID patient image, it should be able to identify. Yes, so this time it is able to identify correctly that it is a COVID patient's X-ray image. So that's how the deep learning can be utilized for various purposes. Similarly, we have another project where we can identify person, whether a person is wearing mask or not wearing mask. So we can supply some examples as I was talking about. And based on the examples of wearing a mask and not wearing mask, the conclusions can be made by the machine. Now go on and switch on my camera. Let's check whether it would be able to identify. So it says no mask with high confidence. And that's the correct response given by the machine. Fine. So I'm not wearing a mask, and this is where it says, okay, the person is predict or identify, classify my input image as person wearing, not wearing a mask. So moving on, when we talk about convergence, we are saying that we have multiple technologies coming up together. That is, if I take the examples, we have artificial intelligence. Within artificial intelligence, for an implementation purpose, we need to have machine learning capabilities into a machine. For that, I can use primitive algorithms, or to give more better capabilities, I can use deep learning mechanism. That is using artificial neural networks. Now, all this algorithms, this mechanism requires a lot of data. So I might use big data technology to fetch the data, store the data, and perform analytics in real time over the data. A data which is huge in size and comes with high velocity. That means it quickly a lot of amount of data is generated, and every instance of time I have to manage a lot of data in real time. Now, this data can be generated through an array of sensors, which is an IoT-based systems or IoT type of system. So this is where a combination of technologies has come together, and to deal with incoming data, huge amount of big data, to provide high capacity storage, to provide high computation power to run the deep neural network algorithms, train the models, and perform the inferences at the edge to of industrial revolutions. So hundreds of years back in 1700th century, there was an invention of steam engines, which was actually utilized in the industrial purposes, industrial mechanical purposes. Then came the electric, and electricity was invented, and machines were then operated by electricity. Then in the 20th century, there was I would say an introduction of computer systems into the industry, where automated machines were developed, computer operated machines were developed, or robotic machineries were developed. Of technologies like IoT, sensor based systems, big data machine operations, robotic machines, which is led by real time data analytics. The smart AI-based machine systems, smart cloud-based smart factories are also there. And now we have deep neural network and artificial intelligence implement. Moving on, apart from combination of these technologies, there is also a concept where we say that in future, the industry will have a combination of human and machine robots that will come together, and together they will perform the industrial operations. That means machine robots would be helping human beings to perform the operations and bring out more productivity and efficiency in the operations. The target is that human beings would be helping human beings are being helped by robots to work better and faster. And aim is to support, not to supersede the human intervention. Talking about this, I would also like to show you a small video that's on Industry 4.0. Just let me know if the audio is not available to you.
The fourth industrial revolution has begun, and you have the chance to be part of it. This isn't going to be like before. It's not about the steam that powered our factories in the first revolution, or the mass production model that dominated the second, or even the emergence of computer-driven systems from the third revolution that we're living in today. Industry 4.0 is about connectivity. It's an opportunity to radically change the way industry responds to the needs of society. As previous industrial revolutions were led by innovations in manufacturing processes and systems, the advancement of Industry 4.0 will be driven by a smart, interconnected, pervasive environment. The opportunities for disruption are huge, and those left behind will feel it acutely. There is still space for leaders of this new revolution to emerge, but the race has already started. Understanding what current leaders are doing will help you join them. KPMG formally examined what those trailblazers were doing in their factories and their offices, and it revealed some thought-provoking findings. Our research highlighted a number of areas that current Industry 4.0 leaders are focused can be developed. Integration is key. The major players are moving away from isolated silo-driven development, which limits scope and value of new projects. Instead, they are moving towards large-scale industry has to offer. Perhaps most importantly, they are not afraid to think big and act bold. This means nurturing innovation, developing disruptive thought processes aimed at devastating the status quo, and looking for opportunity in every element of their value chain, from which products are designed, produced, to who they are sold to and how they are purchased. Your organization may be radically different in the future, with a range of products, services, and processes you can't currently predict. Do you want to join the leaders of Industry 4.0? Can you afford not to? Then our advice is plan ahead. Fight radical change with integrated radical action. And embrace the fact that it's time for manufacturers to step up and start making smart, bold moves. If you don't, you could be left behind. You have this chance. Let us help you take it.
So that's about Industry 4.0. Before we move ahead, I would like to ask the audience, do you have any questions so far? Fine. So can I ask you a question? So for example, we have a building, and in that building there is a basement that has a parking capacity of 100 cars at a time. So consider there is a shopping mall having a basement of parking capacity of 100 cars at a time. Now, if I move in with my car, I need to park my car at the location which is empty, a parking lot which is empty. Fine. So how would I do that? Normally, what we do, we move in and keep searching for an empty location. And there are human helpers which are available there, and they help us out to find okay, these are the empty slot, you can park it here and there, right? Now consider if we want to include these technologies for this solution, what I can do. What is the solution? Can anybody suggest? What would be the solution to find the best location for parking my car? Any ideas? Any suggestions? Okay. So what if I move in and there is a screen in front of me when I'm entering the parking area, and this screen shows the empty parking slots and the one which are already occupied. How this can be made possible? Definitely, we can have some kind of sensor being installed at each of the parking slots. Fine. So if we have a sensor to detect there is a presence of car, and that would send this data of empty or occupied that can be detected through the sensor based data by a system, then it would be possible that we project this onto a screen, a display, and which will tell me, okay, these particular slots are empty and the others are occupied. Now comes to another level where I also need to find out which one is nearest to my current location. How would I do that? To find that, I would need an AI-based systems, an algorithm which will search for a best or shortest path to a nearest empty slot. So again, apart from IoT-based sensor system, I need an AI algorithm as well backing up and providing me the best path to reach the nearest empty slot. Or maybe based on my priority or based on the previous activities, if I have been visiting there very often and I'm already known to that system, so that system can also work as a recommendation system, and it says, okay, you always like to park near the elevators, so we'll show you the best location near the elevator which is closest to you right now, and also have an empty parking slots there, right? That's another way. Now in future, if this has been a regular practice, people are coming in and using this IoT and AI based systems, recommendation systems to park their car in an empty slot and then moving out. This system is continuously working and regularly generating a lot of data on daily basis. You also need to store and keep a backup of this data for future utilization. what we'll do, we'll store this data somewhere. So there could be another technology, that is the cloud computing, can be utilized to continuously upload this data, save this data to a cloud storage. And in future, we can perform the real-time analytics on this data and find out which particular time slots are the busiest for the parking lot, and which is where people, they don't easily find the empty slots, and what can be done as a solution to do that. Fine. It can perform, it can find out the analytics, okay, more space needs to be built, or there is a more rush on specific days in a week, or in a specific time. For example, 10 a.m. to 12 noon, there is a lot of rush, and then thereafter 2-3 hours, there isn't a lot of people coming into the mall. So that's what the analytics can do. So we can use IoT, we can use AI, we can use the deep neural networks here, we can use cloud computing as well. This is one of these very simple examples we can do that. Fine. So moving on, when we are talking about AI, IoT, cloud computing, we talk about a lot of these technologies, and we also target to build a solution, implement solutions using these technologies. So there are certain implementation challenges that comes in, and that is where our focus is for the rest of the session. We'll be focusing on uh, how to handle these challenges. What are the solutions that we have? So the major challenge that we face is implementing or programming for multiple architectures. When we say multiple architectures, that means we might be programming for a system which has a microprocessor. That could be a 32-bit microprocessor. There could be another architecture of 64-bit microprocessor. There could be another architecture which runs on FPGA. There could be an architecture that is not utilizing only the CPUs, but it also can be utilized for processing purpose. So if I start programming in the current scenario, we have to program separately for different architectures. There's no common API or programming language API available that can work for multiple architectures and multiple platforms as well. There's no consistent platform support which is available. Applications are very data centric, and we also need fine, and no organization wants to invest a lot of money where they have to implement for multiple architectures and multiple platforms, or they have to invest a lot of money for various different APIs and tools and hardwares as well. Fine. So what solution we have is this: Intel has come up with a new technological solution here. When we say Intel Technologies for AI, it has a solution which is not only for hardware, but there is a software-based AI acceleration solutions also available. There's a complete AI ecosystem built by Intel, and that provides us the flexibility of using different hardware and hardware architectures using a common software APIs. That's what we call as Intel One API programming model. Intel One API simplifies the problem that we faced working and implementing for various diverse architectures, working and implementing using different libraries, different programming, and different tools. The problems we face related to the high level performance or high performance complications. So what offerings Intel One API has? There are a number of toolkits which are available from Intel One API program. And one of the toolkit is One API base and rendering toolkit. If I talk about this very basic base toolkit, it has a segment of direct programming, API based programming, and analysis debug tools. When we talk about the tools and entities in direct programming, it is the Intel offering of Intel One API DPC++, or what we call as Data Parallel C++, which is built using the syntax of C++ programming, built on the parallel processing capabilities of SYCL programming. So it's a combination of C++ and SYCL that provides us the facility of parallel processing of information, parallel execution. And there are open libraries which are available. Also, there is a compatibility tool, Python as well, which is what also we call as in industry, we call it as a fast Python. It contains the libraries of Python programming. Any libraries that we have been using for mathematical computations, for scientific computations, libraries that we have been using for machine implementations are being optimized, and Intel distribution of those libraries along with the Intel distribution of Python allow us to build the most optimized form of implementations. Also, we have in support for Intel FPGA in the API-based toolkit itself. If I talk about libraries as well, we have a for data analytics debug tool, which is available. VTune Prof achieved. VTune Profiler analyzes your code and tells which part of your code is consuming more clock cycles. And if you use or offload to GPU, or if you use Intel optimized libraries, how much performance gain has been achieved. To gain more insights about the Intel offerings, Intel One API, you can simply search for Intel One API program. And this is where software.intel.com provides you with all information and resources. Also, there is a URL called devcloud.intel.com/oneAPI. Mohammed Amir, and Amir will walk you through the ways how we can implement various kinds of AI-based solutions using Intel technologies. Over to you, Amir.
Yes, thank you so much, Pratik. Am I audible?
Yes, you're audible.
Okay, thank you. Fine, I'll quickly share my screen and then we'll get started. Okay, so hello everyone. My name is Mohammed Amir, and I am also the subject matter expert at FICE Education. So let's begin with the topic for the day. So Pratik has already spoken about the concept of AI convergence, wherein, let's say, we have got artificial intelligence in one part. With that, we have got a lot of other technologies, wherein you can actually combine these two technologies to build one specific model or one specific product, which can be really useful for implementation of solving real world challenges. So I want to now talk about one specific use case, and I want to show you practically how we can actually implement this particular thing, and how we can actually kind of work with this particular model. Okay, so the case study, what I want to talk about first is, so I will be discussing totally 3 case studies. Okay, so the first one, what I want to discuss is with respect to IoT and artificial intelligence. Where are these two things converging, and how we can actually create a genuine product from this particular part. Okay, so this is going to be the first case study. The second case study, what I want to talk about is with respect to, say, machine learning. So I will be using the most popularly used machine learning library, which is called as sklearn. Okay, and I want to mostly come up with a comparison. When you are using normal scikit-learn, what is the time which is required for you to build a project? We'll start with some simple examples, and then we'll go for a little complicated ones as well. Okay, and I will try to show you that particular comparison with respect to Intel version of sklearn. Okay, so we'll use normal sklearn library, which is the traditional machine learning library for building the models. We'll see the time which is required to build a product, or time which is required to build a machine learning model, and then we'll compare it with Intel distribution for this sklearn itself. Okay, and I will also be using in the hands-on, I will also be using the dev cloud which is provided by Intel, as Pratik has already shown you that particular part. right? So I will be using Intel Dev Cloud, wherein on my Intel Dev Cloud, I will be using the Intel distribution of Python, and I will be showing you the time which is considered for doing that. This is going to be the second case study. The third one is where we jump on to the next level and we learn how to build a deep learning model. So in the field of deep learning, we have got a lot of different libraries. I will be using a library by the name of Keras, which is built on top of TensorFlow. Okay, so I will be using the exact same thing here. First, I will do on my local machine, wherein I will run a deep learning model, okay, on normal Python, normal TensorFlow. After that, we will run the exact same code on Intel Dev Cloud, and we will see the time comparison. So the best thing what Intel offers is the time efficiency and the amount of time which is required for you to run. Show you this particular part, and you would understand where exactly Intel is trying to help us. Imagine if the data is less, then it's okay, right? The amount of time which is required to build a model might be less, but let's consider that you have got humongous amount of data. And if you have got a lot of data, then obviously for a machine to get trained will also increase. The time which is required will also eventually increase. But this is where Intel comes out with the high performance computing. So when we are talking about IoT, it's called as Internet of Things. What happens here is that in this particular ecosystem, you will have a lot of sensors, okay, which will eventually take the values from the environment. Let's say I have got a temperature sensor with purpose, okay. I will be using one specific case study wherein let's say that you have got temperature sensor and humidity sensor. So they will be measuring every now and then the temperature value and the humidity value. Okay. And also if you read of Internet of Things, we actually take the data from the sensors. Okay, these are the sensors. This particular sensors value are given to one specific controller. There will be a small, let's say a microcontroller, which will process the data. Okay, once the data is processed, the data would be sent on to the cloud. That is where cloud computing also comes into picture, right? You will be sending, and once the data is on the cloud, we can do real-time analytics. So the case study what I'm discussing here is about that data cloud. So on the cloud, all the data will be stored in the form of database. Okay, let me write down here, say temperature in Bangalore. I stay in Bangalore, so I'm just checking what is the temperature in Bangalore right now. So it says here that I'm sure to Google and type here. So the main important thing what happens here is the value whatever you are able to see, let's say 22 degrees Celsius is right now at 11 o'clock, it is 22 degrees Celsius, right? You can even see the precipitation, what is the level, what is the wind, you are able to see. The best part about this is it eventually tells us the forecasted value as well. So basically if you see here, Wednesday right now it is 22. Thursday, what is going to be the value, it is told here. Okay, then Friday at this particular time, 9 o'clock, what is the value? Saturday, it is telling me the forecasted value. So what is the meaning of forecasting? Forecasting is one machine learning model wherein it kind of predicts the continuous value based on date and time. If you have got date and if you have got time as the independent value, the value which you are trying to predict will be the output. Okay, so let's say you are predicting temperature. You have got a lot of data, and from that data, you are forecasting the future value. Okay, so the same thing is actually happening here, and we will build, I wouldn't say the accurate model, we will build a sensor. Okay, in the field of IoT, I will be using the data which is coming in from sensor. And in the field of AI, I will be using, since I don't have any hardware right now with me, I will be using a simulation tool. I have designed one simulation tool and I will be sharing the link of this particular simulation tool I have designed. Let me just share the link with you. and then we can get started. Okay, so this is the GitHub link. Let me share it quickly with you. Fine. You can just go to this particular link and go to this IoT simulator.apk. If you go to this IoT simulator.apk, I would rather suggest you to do it from your mobile phone, because, and I will just try to show you remotely how this particular software looks like. Okay, so just give me a minute. Let me open my mobile screen. I will just come out and let me open the app which I want to show you. So it is taking some time. Okay, this is the app. This is the simulation. We have got here sensor simulation tool. Basically, the aim of this particular tool is actually to send the temperature value and the humidity value onto the cloud. Okay, as simple as this. You need to just download it and install it. Once you have downloaded and installed it, this is how the simulation tool looks like. So you will have to write a couple of things here. We need to just play around with these two values number. And once we send this particular data, right, the data will eventually go on to the cloud. It will be as if the temperature sensor is actually detecting the temperature and the value is getting processed and it is sent on to the cloud. Okay, so it's a good time right now to talk about sensing demo. Okay, and I'll give your field 1 as temperature, because I want it to detect temperature. Field 2, I'll give it as humidity. Okay, I want it to detect humidity. Fine. Scroll down and click on save channel here. So the channel gets saved, and then you are able to see that there are two fields. The first field will accept the data of temperature. The second field will accept the data for humidity. Okay, this is what we have here right now. Now, what I need to do is I need to send the data from my app, okay, from my Android app to this particular cloud. It is as if the sensors are detecting the temperature and they are sending onto the cloud, right? I'm using a simulation tool here. So how do I do that? For doing that particular part, we need to actually authenticate. Okay, we need to authenticate by providing the channel ID, the first thing. And the second thing what we need to provide here is in the form of API key. So basically, whenever you are dealing with, say, IoT part, you will be playing around with API. API stands for Application Programming Interface. This is one specific interface important softwares. So if I want to connect my ThingSpeak cloud with my Android app, I need to use this API key. So if you go to this API key, it is mentioned here that this is going to be my API key. So let me just go back to my AnyDesk and let me type here the write API key. So write API W, I will have to write it once for this particular part. Let me quickly write this K1 SFU 5BSD. Okay, write 527591. So basically this is where I am telling my channel number. Okay, click on done, and now you would see in your private view that the data has actually started pouring in. If you see here, can you see this 20, 20 for my temperature as 20? For humidity, it is 50. Okay, I can increase the temperature here by again going back to my AnyDesk. If I click on this particular part, by default it is none. I can now select temperature, and I am sending now 24 value. For every 10 seconds, the values are getting updated. Let's see here. Can you see this 24? Okay, I'm sending a couple of more values here just for the sake of understanding. Okay, and let me after that keep down. Fine. So I am trying to send a couple of values here, which you can actually see. 24, and apart from that, let us keep 24 itself for now. Let's just wait. So it is any trouble in understanding this particular thing, you can please ask me. You can put your queries in the comment and I will try to answer. Plot will plot or it will give me the continuous value for upcoming dates. I will keep it like this itself. Let us keep it like this for maybe, a minute or two. Either measure the temperature properly, accurately, and lots of data would be sent on to their database and they will create a machine learning model to predict the upcoming values. Okay, that is where when you go to Google and when you type Bangalore forecast, you will be able to see the values. Fine, that is the main important thing which is happening. And after we have got this particular values, I would not download it right now. After we have got the values, we can actually kind of export that particular data. Okay, so if you go to data import export option, you will see here that we have got two options. Either we can import the data or we can export the data. Okay, so the importing or exporting the data is happening in one specific format called as CSV file. So CSV stands for comma separated values. So with the help of this file, you can actually download the channel's feed, whatever the data is given into the channel, we can eventually download that particular part. And obviously, once the data is downloaded, we can take the data and we can use the Intel distribution for Python, load a library and work on that particular aspect. Okay, so let us wait for some time, and after we have got lot of data, it will be very good for actually forecasting that particular data point. Okay, till now we have got only 15 entries. We'll wait for a couple of more entries, and after that, once we get the real-time data, I want to forecast that exact same to a glance. And until then, in the backend, this particular values will be simulated on the cloud platform. Okay. So if I go here to, let's say, start menu, and if I type normally Anaconda Prompt, let me just type Anaconda Prompt. This is actually a software which we will be using for doing the coding part. Okay, I'll go inside this Anaconda Prompt. By default, if I just write here, let's say Python and press enter, I am in my normal Python environment. It says Python 3.8.8. Okay, this is my normal Python environment. So I'll just exit this. I'll come out. And what I'll do now is I will write here, let's say activate IDP. Okay, what am I doing? Activate IDP. Basically, what it means is I have got one base environment first, which is a normal environment, a normal Python environment. Okay, now I have activated IDP. What is the meaning of IDP? IDP stands for Intel distribution of Python. Okay, now in this IDP, if I write here Python, press enter, the Python version what you get is Python 3.7.11, which is I would say a little previous version, older version, but the main important point here is we have got Intel distribution for Python. Okay, so Intel distribution for Python is what we have here, and if we use this particular part, it will eventually speed up your programming, it will eventually build your model very well and eventually give you better results and better accuracy. Fine, so this is the distribution for Python which I am going to use. Okay, and I will do that particular aspect of forecasting here. In this particular part, I will be using we'll be using one library for taking the data set, we're using another library for visualizing that, we will be using another library for forecasting and showing the final output. Okay, so let us see where are we right now on this particular part. I think so we have got here how many values? 25 values is what I have sent. And I think so this looks good. 25 values can be considered for our backend for working on the forecasting part. Okay, what I'll do is I will just open the Jupyter notebook now, and let me just, I think so I've already opened here. Let me just go back to my this one. Okay, I'll just open my Jupyter notebook, which is already available here. Fine, this is the Jupyter notebook which I am running. I will open one API, okay, And API is basically a folder which I have got. And let me go inside one more folder by the name of IoT and AI. And here I will create a new Python 3 notebook. Fine. So what I can actually do here is I can take that particular data and I can load it here. Fine. And I can go ahead for visualization. I can go ahead for forecasting of that particular data, whatever I have got. So I'll just rename this particular thing very quickly to IoT and AI for forecasting. Okay. I will quickly show you how. Right now what I'll do is, I think so now the time is 11:25. So before taking a quick break, I'll just load in the data and visualize it. After that, we will go ahead and we'll do the forecasting part. Okay. So if I go back to my ThinkSpeak part, if I just go back to ThinkSpeak, and if I go to export, let's just go T values. Okay. 25 to 30 values is what I have here. I will also stop my application because I don't want more data to be considered. Fine, what I'll do is I'll just open the CSV file and show you how the feeds.csv file looks like. This is how it looks like. I have got 32 values. Okay, somewhere around 32 values. Fine, entry values are there. Field 1 is there. Field 1 is basically the temperature. Field 2 is humidity because I have not changed anything with humidity. I will take this file, I will take this feeds CSV file, I will upload it in my Jupyter Notebook environment. Okay. And once I do that, I can just load the data as well. So I'll upload it here. Click on upload and let me go to downloads here, ABC, feeds. I think so feeds 3 is what I have taken now. Click on upload here. Okay. I'll just quickly rename this particular part to say forecast data. Okay, so I have got your forecast data as well. Let me go back. I'll import pandas as PD. Pandas is a library which is used for doing data analysis. Then I'll write df is equal to, basically we are using Python programming now for doing this particular data analysis part and the forecasting part. Okay, so pandas is one library inside this particular data science universe. Okay, so in Python programming we have got this library which is used for data analysis. I am taking the data. Let me write here pd.read_csv. And the data set, what I have taken here is forecast underscore data.csv. Okay, I'll just type in df here and this should give me the output. Can you see here the data is actually given here. The data set is actually considered here and you are able to see the output. So 30 values are there and all the 30 values are actually defined here. I think so 31 IDs are there and you can see here all the 31 values. What we can do now is we can actually use a visualization part wherein I will use created at, which is my date on my x-axis and my field 1 on my y-axis, and I can visualize that particular part as well. Okay, so let me just import the library by the name of matplotlib. Fine. Wait, I think so before that I will have to change this particular thing to date time. Okay, anyways, what we'll do now is we'll just halt for 10 minutes. We'll take a quick break. I think so the time is 11:30 now. So after the break, I will convert it into date time and then I will show you the output for visualization. So if you remember, first part is taking the data, second part is visualization, third part is forecasting. We'll do these 3 parts and I'll show you how we can actually take the concept from IoT and implement it in AI. Okay, so let's take a quick break and after that we'll meet at 11:40. Ma'am, are you there? We'll take a short break now.
Yes, sir. Okay, sir.
Yes, okay. We'll meet at 11:40.
Yeah, right, sir. So dear participants, again, we'll meet at 11:40. So let's take a 10 minutes break.
Okay, so hello everyone, welcome back. I hope my voice is audible. Pratik, am I audible?
Yes, sir.
Yes. Okay, fine, thank you. Fine, let us begin with the session. So I have taken the data set here already and I have created a data frame from it. The next thing what I'll do is I have to plot this particular data. But before plotting this particular data, let me mention that the value what we have here in created at, it is by default in string format. If the data is in string format, we will not be able to plot it. We need to convert this particular data into the date and time format. So let me quickly convert this particular thing by writing here df of, and the column name is created at. Okay, I'll equate it to pd dot to date time. So when I write here 2 underscore date time, it gets converted into date time part. Okay, so what am I converting here? I am converting the same df of created at, and I'll use here one specific format parameter. So basically this format parameter will actually tell my format what I need to consider. Let's say that this is the format which I have. I'll just copy one of this and paste it here. I will have to specify, instead of the year, I will have to write here percentage y, which means that I'm taking year. Okay, then percentage m, which means that I'm taking month. Percentage d, which means that I am writing d. I'm writing a general value here. Next, I have percentage capital H. After that, I have got percentage m, and then I have got percentage s. Okay, so these three things will indicate that I am taking hours, minutes, and seconds, and after that ist as it is towards the end. So when I convert this now, right, it will be shown that the value which is in the form of string will be converted into the data of date and time, whatever is required. Now you can go ahead and plot the graph. So if I write here plt.scatter of df of, let's say, created at, which is going to be in the x-axis, and then I'll write df of, what is the value? I've written here field 1, right? So I'll write here field 1. Okay, and then I'll just do plt.show. That means I'm displaying. So you would notice that the data what we have got is as follows. This is the plotting, the visualization part what we have got. Okay, so I can make it more better by just putting here plt.figure. Okay, and I'll write here, let's say plt dot fig size. Okay, and I'll write here, say figure is equal to, figure of fig size is equal to, let me give here some size 10,5 and then run the code. You'd notice that it becomes big. I think so 10 is small. Let me make it 5 and then I'll write here 3. You'd notice that the figure is actually displayed in the most clean manner, right? You can also put a line graph here by just indicating, instead of plot, instead of scatter, write here plot. And you'd notice that you are getting the plot here. So basically, this is the original data what we have. We need to understand what can be the forecasted data. Okay, so the original data is given here. We need to understand what is going to be the forecasted data. Now for forecasting, we need only 2 columns. The first column what we have here is with respect to say created at, which is my date, and the second column is temperature. So I'll write here created at. This particular column should be considered or should be renamed as DS, or it is the date column what I need. And the second column what I have, let's say field 1, I need to rename this particular column to Y. Basically, this one is telling me the concept or the value with respect to what you need to predict. Okay, so I've got here 2 values which I need to rename. I'll write here df is equal to df dot rename What am I renaming? I am renaming my columns. Which columns am I renaming? I am renaming created at. I should rename this particular thing to DS. Okay. And then I should rename field 1 to Y. As simple as this. Okay. Why are we doing this? Because the library which we are going to use, right, it would need to be in such a way that the column names are DS and Y. If it is something else, it is not going to work. It will give you an error. I'll write here df underscore new is equal to, let me take df of, let's say DS comma Y. Okay, I'm taking only 2 columns. I'll just show you the data frame, how it looks like. This is the data frame what I have. Okay. And now I can go ahead and I can just create a forecasting model. So to create a forecasting model, I'll be using one library called as FB Profit. I'll import Profit from here. So what this Profit library does is it asks for one specific data and then it kind of predicts the forecasted part. Okay. I'll create a model here by writing model is equal to Profit. And then after that, let me write model.fit. So basically model.fit is the place where you eventually run or train your model. After that, I will create a variable called as forecast, which will help me make my future data frame. So I can write here make underscore future underscore data frame. What is happening here? We are just telling the machine for how much data you want to predict. I'll write here periods is equal to, say I want to predict for 50 more data points, and the frequency in which it has to do is by considering for every second. So I'll write here S, which will consider for every second. And now I can create a forecasting model. Okay. So I can just predict the output by taking forecast inside this. So it will create a forecasted model here. And it is giving me a couple of warnings which I need to just ignore it. That is not a problem. I can directly go ahead and do model.plot. Okay, I'm plotting something now. What am I plotting? I'm plotting forecast. Okay, and let me just run it. You would notice that this is how the forecasted value looks like. Okay. This is a very simple forecasted value, what it is showing. Let us try to understand what exactly this particular thing is trying to tell and how we can create a clear-cut evaluation from this. Okay, because whatever the model I have created right now, it is not proper. Okay, it is not fetching the value properly and it is not giving me the correct results. I need to do some change here. Okay, what is that change? What fine-tuning I need to do? Let us understand. So the first thing is I'll just go up and I'll take the figure part. So fig size I will take, and let me just put here fig size value. This is the first thing which I do. I'm making it small so that it looks neat and you are able to see this. The second thing what I need to do here is whatever the black dots we have, these are the original points. Okay, what I have got as the blue line, this is the best fit line which I am getting from my regression model, from my forecasting model. But it is not fitting all of the black points properly, right? So I need to give here a new parameter. I need to give here a new parameter for adjusting itself. That parameter name is change point underscore prior scale. Prior. This is a new point which I need to use. I'll just give this particular value as Y. Okay, sorry, 1. I'm giving the highest value as 1. Let me run this now. And now you would see that your model performs a lot better. Are you able to see that the values are now being considered? The pattern is now being recognized by the model and it is able to build much better model than it had built before. Okay, so that is the power of fine tuning. Now you can see here till the point, black point ends. This particular data is gone here. After that, whatever the data you are getting, that is the forecasted value. Are you understanding the point? till the point where we have black points here, black dots, that is the original point, and we have got here the best fit line. After that, the line what we have with the blue extremes, these are the forecasted points, and this is how forecasting happens. Right now we are considering with respect to only seconds. We can consider it with respect to minutes, hours, and lots of other things. Since we had taken the value second wise, I am also forecasting second wise. This is considered to be the best practice. Okay, if in case you have taken, let's say you have taken hourly basis, the temperature and the humidity, and you want to build a machine learning model, a forecasting model with that, you can just go up here and instead of writing say frequency as S, just put as H, you will get hourly data. If you write M, you will get for monthly forecasting. Okay, you can do a lot of variations here. Fine, this is the place wherein IoT and artificial intelligence are actually converging. Okay, this is the case study which I wanted to discuss. We had seen the sensors getting the value from the environment, temperature and humidity. The data is stored on the cloud computing platform, and I have exported the data onto my Jupyter notebook. Fine, this is the first case study. We come to a conclusion for our first case study here. Okay, let's go for the second case study. So this is my first case study wherein both the technologies are converging. I want to now go to the second case study wherein I want to talk about machine learning with respect to sklearn. So what I'll do here is I will take one data in sklearn library and I will build a machine learning model. So the case study what I want to discuss here is with respect to the prediction of house price. Let's say that a person wants to buy a house, okay, and I have got one specific data which is called as California housing data. Okay, I'll show you that particular data also. So there are a couple of columns which actually will help me deduce what are the important features which are required for calculating the price of a land. Let's talk in simple terms. If you want to buy any plot of land, you will be checking what is the area of that particular land. That is the first thing, right? That is the main important criteria which is dependent on. Apart from that, it will also check, let's say, whether it is near to the prime locality or not. Is it near to main road? If it is near to main road, airports, or then the higher the price would eventually be higher, right? So there are a lot of different criteria which you need to consider. So what we'll do is we will use one data set which is called as California housing data set, one of the most popular data set, and I'll build a machine learning model. Okay, and after that I will see the exact same model on my dev cloud. Right now I'm going to do it on my local Python machine, and after that I will see on my dev cloud. The moment I use my program on my dev cloud, it will take much lesser time. Now that I've spoken about time, I will tell you what exactly can we use for finding the time which is required for running any program. Okay, so this is my standard I would say program which I will use in each and every say case study which I'm going to do right now, any project I take. So I am importing one time module, time library. As you can see here, I am taking the starting time. This is the starting time. Okay, and I will do all my tasks. So line 1, line 2, whatever I want. Right now I'm just doing hello world to just display, and I will take the ending time. So once I subtract starting time with ending time, the time what I get is the final time, which tells me that to run this particular line, how much time is it taking? So for hello world, right, it will take somewhere around, let's say 0.01 seconds or 0.02 seconds. It happens very fast because we are not doing anything much. But let's say if I am building a machine learning model, how much time will it take? How much time will it take on normal Python? How much time will it take on Intel Python? We will compare and we'll understand why Intel is better. Okay, we'll practically see that particular part. Fine, so I'll go back to my Jupyter notebook. Let me just come back. I've got here sklearn optimized value. Let me open this. And as you can see here, I'm taking here California housing data set. Okay. So what is this code all about? I'll tell you the summary in very simple terms. I'm importing a couple of libraries. The first library, time, is for detecting the time duration, the start and the end duration, so that I can find the difference. The next library what I'm using is sklearn, wherein I can implement my machine learning model. The third library what I'm going to use is dataset to fetch my dataset, whatever my dataset is available. After that, I'm using a couple of libraries for visualization, couple of libraries for evaluation, and also for doing some kind of pre-processing. Okay, pre-processing means the data, whatever I have got, it is not in the format which I can give to my machine. I need to do some sort of pre-processing, and then I need to send it to the machine. So I take the data set first, I apply some kind of pre-processing, I separate my input data and output data from the data set. Then I apply the splitting of data. So splitting of data means that I have got my training data, I have got my testing data. I will use my training data to train my machine. Once my machine is trained, I will use my testing data for prediction. So once I use my testing data for prediction, I can compare whether my data is giving me the correct answer or not. Is it being compared properly or not? Okay. So after that, we can eventually say find the evaluation metrics. You can just find what exactly is the error and total time which is required to build the model. Okay, so the demonstration what I'm going to show you right now is not with respect to building a machine learning model and checking the output, but it is with respect to the time duration which it takes to run this particular code. And if you can clearly see here, when I had run this particular code previously, it had taken somewhere around 60 seconds to run this particular code. Let me just run it again to help you understand how much time is it taking. I'm running now this in real time. Okay. And let us just wait. It will take somewhere around 60 seconds to run this code. The data set is not that huge here, but still it takes somewhere around 60 seconds to run the code. If the same code is implemented on Dev Cloud, let me open Dev Cloud also and show you. Let's say this is my Dev Cloud. It is loading. Let's just wait for a while. It will take some time to load. I think so. Network is okay. Let's see. We'll just wait for a while. And once it gets loaded, right, you will be able to see the difference for yourself. It is just loading right now. Let's just give it a minute. It's just opening for the very first time. When it opens, since it is a virtual machine, it takes some time. I'll go to optimized scikit-learn code here. Okay. The exact same code what I have used there is what you can see here. So I have got your California housing data set, correct? What I'm going to do right now is I'm going to fetch sklearn patch from this particular Intel library. Let me just enable the Intel extension for sklearn here. Wait for some time and it will fetch the sklearn from Intel. Once it fetches sklearn from Intel, we are ready to go for applying our machine learning model on Dev Cloud. Okay. So see here, Intel extension for sklearn is enabled. That is what it says. Now scroll down and run this particular code. The exact same code is what I have used. California housing dataset. Let me run it. Okay. So let's just wait. Let us see how much time does it print here. And okay, we have got already the output. It took 5.59 seconds to run the exact same code. How much time does it take here? It is taken 59.5 seconds. Which means whatever you run on Dev Cloud, it is happening in 1/10 of the total time what you are taking on a local Python machine. Are you understanding the difference? I want you to pay note to this particular line. So it took 59.55 seconds. That means the normal Python code. And whatever we have done online, it took 5.59 seconds. The reason is very simple. We are using here Intel Xeon processor, which are processors of the highest speed. And on top of it, we are using Intel distribution of Python. We have also enabled Intel scikit-learn. That is why it is happening very quickly. And the best part is it will give you the same results. So we can now choose which one we want to use, right? We want to use local environment, or we want to use something which is fetching us the same result, but with lesser time. So this is the utilization of hardware which is happening in the backend. Okay. With the help of this, again, you will be able to predict the output very easily. You can just give whatever the inputs you want and you will be able to get the output. Again, as I've told you that our main focus will be on understanding what exactly is the time duration which is required to run on local system, as well as case study wherein I have taken machine learning with respect to sklearn for finding the price of one specific house. The last case study which I want to discuss is with respect to deep learning. So in the field of deep learning, we have got a lot of libraries. The most commonly used library is called as Keras, which is built on top of TensorFlow. So what I have done here is I have taken one data set again. Let me just show you that. I'll close this, and I'll open optimized TensorFlow. By the way, all the codes, whatever I have used right now, I will be sharing you a link, and all the codes are available on that particular link. Okay. So I'm using TensorFlow here. Let me just import and check the version. I'm using TensorFlow, I think so 2.2, okay, on my local machine. And after that, what I'll do is, even before building a model wherein it is, developing one specific model for a data set of fashion, I want to show you something simple. Let's do something simple first. So I have imported TensorFlow here. I will also import TensorFlow on my cloud as well, so that it doesn't take that much time. Okay. And okay, I think so this is fine. The next thing what I'll do is, I would want to run one specific code wherein I am taking two variables which are randomly generated matrix, okay, and they're following a normal distribution pattern. So they are the random generated matrix values. How many values are there? 10,000 rows and 10,000 columns. Okay, it's a very big matrix, and I'm doing matrix multiplication here. I'm going to perform matrix multiplication for these two matrices. Okay. Obviously, you know that for doing matrix multiplication, it takes a lot of time. Even a computer can take some time to do that particular task. So when we use the normal Python TensorFlow, how much time does it take? Previously, it had taken somewhere around 13 seconds. Let us see how much time is it taking right now. And the same time, we will compare it online as well. Okay. So this one I am doing just to help you understand the power of Intel processors when you are doing simple mathematics. So see here, it is taking 12.18 seconds. Let me run the same code on the Intel cloud. Let's see. Previously, it had taken 2.2 seconds. Wait. See, it took 2.67 seconds. So 2.67 seconds, compare it with 12. So right now it is 1/5 of the total time what it had taken, right? So this is where Intel processors are powerful. Intel distribution of Python is becoming more popular. It is more efficient. I'll show you one more case study wherein I want the machine learning model to differentiate different types of images which are in the form of fashion. Okay, let's say I want a machine learning model to differentiate whether it is a t-shirt or a trouser or a pullover or a dress, coat, sandal, shirt, sneaker, bag or ankle boot. There are totally 10 objects and I want to create a machine learning model to differentiate these 10 objects. Okay, so how do I do that? I first take the data set again. The data set is preloaded from Keras library. Okay, it is already available in the form of fashion MNIST. Then I write the labels. What is it? It is t-shirt, trouser, pullover, whatever it is, 10 labels. And then I take the input value. I kind of reshape it so that I build my model very easily. Okay, I've reshaped the dimensions here. Then I go through the process of normalization and one hot encoding. Basically this process so that we can actually do the formatting part very easily. If you remember, I had told you that the data is not necessary that it will be in a format which is accepted by a machine. You need to do some kind of pre-processing. So these are the pre-processing techniques which we use for making sure that our data is given to the machine properly. After that, I split my data into training and testing, and then I build a model here. Now, the point to be noted, the model what I'm building here is called as convolutional neural network model. So basically, convolutional neural network, or in short CNN, is used for differentiating two different images. Let's say I've got an image of a, say, t-shirt, and I've got image of a trouser. If you want machine to differentiate between these two, you will be using mostly CNN. In the backend of CNN, it will recognize the pattern. It will detect the outliers, whatever is there. And based on that, it will tell that, okay, this is a cloth, or this is a t-shirt, and this is a trouser. So we need to build a neural network model here. The lines which I have highlighted here will eventually help you to build a CNN model with respect to a lot of filters, a lot of layers which are given here. Okay. At the end, if you note, we have got 10 values here because my model will give me the probability for totally 10 important features or 10 objects which we are considering. Okay. And after that, we are storing the weights of neural network. So in a machine learning model, in a neural network model, the main important thing what you need to deal with are two important constants, which are called as weights and bias. These are also called as trainable parameters. So we need to save this best set of weights and bias. And if we have the best set of weights and bias, we can consider that our model has developed properly. Fine, this particular thing, this particular concept or this particular training takes a lot of time. Let me just see here. What exactly have I given here? So let me just run this particular code and let us see how much time duration does it take to run this particular model. Okay. I am running this particular model now. It is displaying me the shape. It is saying that totally there are 60,000 images in the training data, 10,000 images in the testing data. Okay. Scroll down, you will be able to see the model network. We have built a CNN model. Okay. And at the end, we are able to see only 10 neurons, which indicates 10 different categories. If you see here, I am training my model. Okay. And you can see here clearly that the estimated time which is taken for running only one iteration, we call it as one epoch in TensorFlow terminology, which means that my model is trying to learn what exactly is my input and map it with my output. So you can see here loss and accuracy being indicated as well. It is taking somewhere around 1 minute to run one epoch. So machine learning model can run several epochs also. I'm just trying to tell you one epoch, how much time it is taking. Let's see on the dev cloud also how much time does it take to run the model. So I'll go back to my dev cloud and I'll run the exact same code. I will also give here the same epochs as one itself. Let me run the code. Let us see how much time duration does it take. Again, it prints the shape, it prints the model, and it starts training. So the time what is required on the dev cloud is less than 15 seconds, which means within 15 seconds, you are able to run one iteration. And the same time, what you are taking in normal Python is more than a minute. So 15 seconds and 60, 70 seconds, there is a time duration. There is a time difference, right? At the end, it will print in one sentence what is the total time which is taken so that we can compare this. I think so this has taken totally 104 seconds to get the output. Okay, let us see how much time is it taken here. Wait. So it has taken 48 seconds, which is telling us that it took just the half time, right? This took 100 seconds. This took 40 seconds. So it is, I would say one third or 1 second. So half of the total time what it has taken. And we are getting the exact same output. If you see here, the accuracy is also somewhere around 89%, 83 to 89%. Here also, I guess we are getting the same thing. See here, 83 to 89% itself. So the main important point here, what I want to tell now is, whenever we are using Intel distribution of Python, or whenever you're using the dev cloud, it is giving us the same result, but it is taking much lesser time to do that particular task. So if we are allowed to choose between two important cases wherein you can build the machine learning model with say 40 seconds and you can build the machine learning model with let's say 10 seconds, then which one would you choose? Obviously you would choose with the one which is having less time, because if your date, the time what is taken for running let's say 100 epoch on local machine is several hours, it might take even weeks to complete that particular task. The same thing, if it could be done in a couple of minutes on Intel platform, definitely you would choose Intel, right? So this is where Intel is actually helping AI developers, machine learning developers to eventually get the time duration whatever is required for training and also for inferencing, so that you build really quickly the machine learning models and you can actually deploy it in real time. Okay, so that was my third case study which I wanted to discuss. So the first case study, just to summarize you, I had talked about IoT and AI convergence with respect to forecasting and machine learning part. Also, we had spoken about cloud computing wherein the data is stored. The second case study was with respect to price prediction using sklearn library. I had done the same module, the same code on local platform as well as on dev cloud. Dev cloud outperformed the local platform by a lot of margin, right? A bigger margin. Finally, I had shown you fashion recognition image data set with respect to Keras programming. I had done it on my local machine. It took somewhere around 100 seconds. When I had done the same thing on my dev cloud, it took less than a minute. 48 seconds is what it had taken, right? So these were the three case study which I had discussed with respect to Intel software. Now I would hand over to Pratik for demonstrating you on another case study. So he will be taking you over to say image classification specifically related to computer vision, wherein you would be able to differentiate whether a face is detected or not. So Pratik will talk more about that. But before handing over to Pratik, if you have any queries related to whatever case study I have discussed, you can please ask me. If you don't have queries, then I'll hand it over to Pratik and Pratik can walk you through the demonstration part. Any queries from any faculty? Yes, no, any response? Okay, so I guess there are no queries. I have sent you the sensor simulator IoT code in the GitHub, which is hosted on the GitHub platform. I have sent you in the comment section. I will also send you the GitHub link of all the other codes which I have used for Intel One API, so that you can keep that for your reference. And yes, Pratik, you can take over now.
Thanks, Amir. And thank you so much for a very informative session from your side. It was really useful. So now what I'll do, I'll continue from here and I'll share my screen. And I'll talk about another technology and offering from Intel, that is Intel Openvino Toolkit. So we just saw some demonstrations from Amir that was related to IoT, machine learning. We created a predictive model to predict some values like a temperature value, what would be the values in future. And we also saw a CNN model for image classification on processing. So Openvino Toolkit is another offering from Intel. Intel distribution of Openvino specifically. It is a toolkit that enables us to optimize, tune, and run the comprehensive AI inference models. And these models can be used to build computer vision applications. Also, apart from that, it provides us with a model optimizer toolkit and runtime and development tools all also available with Openvino Toolkit. What benefits that we get from Openvino is, while we use Openvino, we can get in high performance computation powers, especially when we are implementing deep learning algorithms like convolution neural network. We are image processing and classification, finding the objects in the image. Sorry. And similar kind of demonstration I'll show you today, that is based on Intel Openvino Toolkit, that will help us to identify the face from the scene image, right? So to do that, I'll just move to my directory where I have my code, and on my screen you can see I have a command line which is directed towards the directory where I have the project. And in this project, I have also activated IDP, that is Intel distribution of Python, for faster execution. And to run that, I'll just use the Python face detection.py file. Now, what this particular program will do is, when I run this, it will open up the camera of my device, that is my laptop, and it will start capturing the faces which would be available on screen, right? So any camera captured image, if it has a face, a human face, it would be detected and it would be marked with a rectangle. So that's the simple face detection method or face detection algorithm that we are using. I hope you are able to see the output which is available here on my screen. So it is able to detect my face. And to show you how it does that, I'll just open the program as well. And this is where, if you remember, we created a model earlier. We created a model, like, for example, we created a model for convolution neural network, or we created a model for prediction. And in that model, we were actually training the model parameters using model fit, and then predicting out some values, or classification prediction is done. So the same model, using the Python programming or any other programming supported, can also be saved for permanent storage onto the drive. And from that, model optimizer tool of Openvino Toolkit can convert that model into couple of files, that is the bin file and XML file. That's what we have in here. We are importing those files. It's in the same directory where my project is. There's bin file and an XML file. So what does this file is doing is this: whenever we train a model, we first define a configuration of the model, and then the model parameters are trained to an optimized form. So the configuration of the model is saved in XML file, and any trained parameter values are saved in the binary file or the bin file. And in this OpenCV program, we are using this model parameters and configuration to perform the inference. And if I wish to perform the inference at the CPU level, I can use the target device as CPU. Instead, if I would have wished to do it on the edge device, like a neural stick or an AI accelerator, I would have written for Intel Neural Stick 2, I would have written something called as Myriad. Now, what this Myriad device is, I'll just open my camera and I'll show you. I have this device that looks similar to a pen drive. This is a small device, very small device, and this is a USB device actually. It has got a USB port as well. So this device is Intel Neural Stick. I hope it is visible. So this is Intel Neural Stick. What I'll do, I'll place it, I'll plug this device on my laptop system. And as you have seen, I have directed my program to use this target device as Myriad. That is the code name for Intel Neural Stick 2. Fine. So I'll just save this, and if I run my program once again, so this time instead of using my device CPU, it will start using the edge device, that is the Intel Neural Stick. Intel neural stick would be utilized, and this neural stick is actually processing or performing all the computations which are required to run this model for face detection. Fine. Similarly, I'll show you another demonstration which is also similar to one I have just shown to you. Let me go to another directory, that is age and gender detection. And there I have few files. I can show you in the directory structure as well. So, right. So I have a program and I have the supported model files as well available here. Fine. If I go back to the structure on the command line, so this program actually is a combination of multiple models. So one of the model is to detect a face, which we have just executed in the previous demonstration. And there are a couple of models to detect the gender and the age as well. Fine. So we have a model which is a face detector model, then a cafe model is also there for detecting the age and gender. So age model, face model, and gender model. These are the three models we are executing. Age model is being targeted on CPU, gender on CPU, and the face detection is also on CPU. Right now we are targeting everything on CPU. So if I run this using my Intel distribution of Python, so again, this would be not only able to detect the face, but it is also telling that the gender is male and the age is somewhere in the range of 25 to 35 or about that, an approximate range of age. And that keeps changing dynamically. Fine. And similarly, using my Myriad device, I can change any or offload any of the model to be executed on the Intel neural stick. So for example, I'll just offload the age or maybe the gender to Myriad. When we are working with the edge devices, I don't have a complete CPU system. I have a low-end processing system. For example, I might have a Raspberry Pi device, which is a mini computer, but does not have a very sophisticated computation power. So I can attach on the USB port, I can attach an Intel Neural Stick Edge device, which is an AI accelerator, and it can help me out to offload some of the execution load onto that device. So again, if I run the similar program, and this time it is more stable to detect the age because I have offloaded age to Myriad device, and it is not fluctuating anymore. It is more stable because a dedicated separate processing unit has been provided for the age detection model. The face detection and the gender detection is being executed on CPU, and some of the load of CPU is now offloaded to the Myriad device, that is the Intel Neural Stick 2. So that's how another offering, not only in terms of software, but in terms of hardware as well. Another offering from Intel is the Openvino Toolkit as a software solution, and the edge device accelerators like neural model. And this Openvino model can be executed. It is compatible with different kind of architectures as well as various different platforms. So this is where, to summarize again, in this session, we have discussed about artificial intelligence, machine learning, and deep learning, its convergence with IoT technology. Then talking about how cloud computing converged with these latest technologies to provide a better, efficient, and in a cost-effective manner. Further, we saw how Industry 4.0 demonstration implementations and computer vision application through Intel Openvino. We walk you through the Intel One API offerings, base and HPC toolkits, and also the Intel Dev Cloud environment, which can be used to build and test your applications. That's all been the part of the discussion in the session today. Thank you so much for attending the session. Now we are open for any queries and questions you have.
Dear participants, if you have any queries, please ask. Otherwise, you can post in the chat box.
Yeah, that's also a convenient option. You can write in the chat box. Dear participants, we expect to have an active participation and healthy discussion over the technologies. Please let us know if you have any query or want to share any of your experience, or maybe any discussion about the technologies you might have been already working on, some research you might have done.
Thank you so much, sir, for spending your period with these entire participants. Thank you, sir. Thank you so much, sir.
Thank you, ma'am. Fine. Thank you so much, ma'am. Thanks all the participants for attending the session, and I guess we can stop here. Thanks, Amir, as well, for the interactive informations.
Thank you. Thank you so much. Thank you, everyone.
Thank you. Bye.
Thanks.